So in last video, I briefly touched on named entity recognition, and the goal was for my web scraping project to be easier to maintain. And then I have another problem, which you see while I'm scraping. Every now and then, these dogs come in with a dog breed, and I check my database for if the Dogo Argentino is already stored in there, for example. But every now and then, these breeds come in another spelling. Well, either it's a spelling mistake or in a different language. It's not possible for me to predict all potential spelling mistakes and all possible translations of the dog breed. So let's try to solve that with machine learning or deep learning. Sentence similarity with the ID that, for example, Dogo Argentino and Dogo Argentino are going to be in the training data with a high score for similarity. And then once I train the model, it'll be able to predict that something slightly differently spelled as a match. And the same for translations. So let's just quickly look at this. So the sentence 1, first sentence, ML.NET 2.0 just released, which is a long time ago now, but sentence 2, there is a new version of ML.NET and the similarity is 5. So that's the best similarity score. And then down below, sentence 1, sentence 2, it's basically the same sentence 1, but the rain in Spain, something completely uncorrelated. The rain in Spain stays mainly in the plain is similarity of a 1. So the worst score. It's a range between 1 and 5. Then we're simply training the model. So the sentence similarity model we're training, we're passing the label column, which is a similarity, the float score. Then sentence 1 is the source and sentence 2 is the target. And if we train this model on enough examples with similarity scores between slightly varying sentences, it should then be able to make a prediction about similarity. So again, I found a link in Fyodor's repository, although I think this is just a copy of the original ML.NET 2.0 sample, but I think he may have added another dataset, synthetic sentence similarity dataset. So let's quickly look at that, which is this one. Zoom in a bit. And it's basically sentence 1, sentence 2, similarity score. The sky is blue, the sky is clear and blue. And then he's got scores between 0 and 1. And then this is a less similar score. It's raining heavily outside, the weather is sunny and bright. The meaning is opposite, let's say. Car is new and fast, the vehicle is old and slow, which is a low similarity score. Just wanted to see how it's built, what the structure is, so we can build our own custom dataset on, to train our model on dog breeds. Then there's another dataset which has a bit more columns: ID, product UID, product title, search term, relevance to relevance, and product description. This seems to be more like, let's say, a user searches for a product, and then we're going to try to find a match between the search term and the product description, if I'm not mistaken. So that could be a more real use case, and that seems to, for me, that sounds a bit like semantic search, which I'm gonna try to achieve and maybe in another video. But let's continue with the simple example. Some links. So let's quickly check this out, how to label, some more links about embeddings, but that may be for an alternative approach or an improvement on this. How to label data for sentence similarity. These embeddings and these vectors are relevant because I think maybe this could also help building the data set, or just completely tackle the sentence similarity case altogether, depending on how custom your data set, your domain data is. In my case, it's all dog breed names. So very shortly, without going too much into depth, let's say you generate embeddings or vectors from specific words like cat and dog, And then king and queen, for example, king and queen are going to be more similar than than king and cat, for example, or queen and cat. The same for dog and king is going to be less close together than cat and dog. But for different dog species, well, it's all dogs, so could be interesting to see what happens there. I already did this. So I basically have sentence 1, sentence 2, and the similarity between, I did it between 1 and 5. And then I'll show you in a bit. So between 1 and 5, because I was wondering how to really give these similarity scores by hand, so manually, or doing it programmatically without using the vectors or embeddings, since that would already require a pre-trained model. So then it states this is an AI-generated response, binary labeling, assign a binary label +1 or -1 for each pair sentence, indicating whether they are similar or dissimilar. So that could perfectly be 0 or 1 as well, I think, binary. Well, it may not capture the nuances of similarity. Yeah, if it's just binary, you're not going to get like slightly similar or things like that. Which brings me to the next one, assign numerical labels to represent the degree of similarity between two sentences. Completely dissimilar for 1, somewhat dissimilar, 2, neutral or no clear relationship, 3, somewhat similar, 4, completely similar, 5. This should be an identical match. In my dataset, I'm going to have 5s for identical matches, and then more than 4 for all the aliases of a dog breed. I will show you in a bit. That's basically the ID. Then I did some data prepping. So I've got all the dog breeds, Alaskan Malamute, and then some aliases, which are slight variations of the spelling, but could also be in a different language. American Akita, Amerikaanse Akita, and Dutch Akita, which is like the short names and so on, so aliases. For the Cocker Spaniel, you have quite a few possible wrong spellings and so on, and translations. American Pit Bull Terrier, yeah, you can call it a pit bull or you can call it all kinds of things, and so on. So then I generated this dataset from that, basically looping over all the breeds and all the aliases and programmatically assigning a similarity score. So I've got about almost 20,000 records, which is decent. This time I did it comma separated, so most similar, Alaskan Malamute with Alaskan Malamute is an exact match. So all the breeds and the aliases with each other are exact matches. And let's see. Well, let's just see the rest. So 4.5 is an Alaskan Malamute with an Alaska Malamute. Maybe I should bump it up a bit more, 4.8 or something. But anyway, Alaska Malamute with an Alaska Malamute with a dash. This should actually be like a 5 because yeah, it's just a separating character. Akita, American Akita, since it's an alias, it's a 4.5. These are all aliases as well, 4.5. Let's see another value. Then we have like a 3.60. It's likely when there's matching words, which I wrote some custom code for. But I think we've already seen well, there's definitely NLP techniques to cover that instead of writing it myself. So I wanted to say we already saw a bag of words in the spam or ham email classification example, which was under naive Bayes. And they were basically made bags of words, but naively on the count of the occurrence of the words. So the quick brown fox jumps over the lazy dog. This becomes the vector. with two instances of the, because there's a the here and a the there. This becomes the numerical representation, the vector. Then the embedding is something a step further, more like the. Anyhow, this is simple. This is too simple, because if I did that on my example, of course, there's differently spelled words which would not result in a good counting if you follow along. For example, Cocker Spaniel and American Cocker Spaniel, that would be okay. But let's say there's it's slightly spelled slightly differently, then that wouldn't be well, the bag of words wouldn't fix that, if I'm not mistaken. So we'll need to find another way to do that. Maybe embedding-based approach. Since embeddings tend to be more robust, can be multilingual, and hopefully can tackle these small spelling errors. But let's keep that for another video, because I do feel like I want to touch on it, but I'm not going to now. And even this Cocker Spaniel Anglais, American Cocker Spaniel, the word order doesn't really matter. I did anyhow, let's check what's a 3 score. It's basically just American. Okay, there's only one matching word. Okay, American, but that's not so good. Akita and Bulldog. That is likely going to impact my model negatively. Although, let's say a user starts searching for dog breeds and it types American, having the Bulldog pop up wouldn't be the worst. But I think this should actually be a way lower score. American Akita, American Bulldog. Because it's a completely different breed. This American Akita and Japanese Akita could then be a... Well, this is valid, because Akita. And it's... this is a more valid one, let's say. Akita Inu and American Akita has some relevance. But then we should like map maybe... How do you call that? Some kind of some other column which says, okay, these are part of the Akita family, let's say, or the Labrador Retriever, or the Retriever family, things like that. We could make an extra column for that, and then calculate similarity on that too. Well, let that impact similarity for a better model, but I didn't go to that extent just yet. Anyhow, you can kind of see how the dataset is labeled. The pointers and the pointers, they may have like some relevance or similarity, but not too much. At least more than an American Bulldog and an American Akita. But yeah, so that's a mistake I hadn't got before. That's basically how the dataset is built. Yorkshire Terrier and Whippet has a bad similarity, and there's a lot of bad similarities if there's no matching words and it's not within the aliases and so on. Okay. Let's see, data prep. So I basically just load in the dog breed.json with the breed response, and the alias response comes from my application. I did remove all the IDs and slugs and things like that, since that's not necessary for this. Then a JSON file handler just to read it out and to save it as the, well, overwrite it, let's say, without the IDs and everything, which I already did. And then CSV handler simply to get our CSV file. Oops. So we're just reading the breed responses, and if we then take a look at the first, some random examples, we have a Sharpei with a Cantonese Sharpei, Chinese fighting dog Sharpei, a pug Mopshond, mopshond in Dutch, Mexican hairless dog, Mexicaanse naakthond in Dutch, for example. So these are the aliases. Then quickly wrote this score similar word count. So here we should likely make some exception about that American bulldog and American Akita. Yeah, this is too simple. This is basically just comparing the similar words within the set and then giving a score based on the matching word count and then scale it between 1 and 5. So the idea would be flat code retriever. I add a $, just to test, and Labrador retriever should get some similarity. If I add $, and $, it should get even more similarity, but this is not it's not an actual breed, the entire thing. It's either a $, retriever or a flat code retriever or Labrador retriever or golden retriever and so on. You know the breeds. Then I'm building the CSV, best similarity score 5. High similarity score is a 4.5, is mainly for the aliases, since I want to have it recognized that that's the same dog breed. Maybe I should give an even higher score, but okay. Low similarity is just a 1. And then all the rest that's like slightly similar is going to be calculated by the word count, which is too naive. Again, there's likely better approaches. Bag of words, I don't think it's going to... It's also a word counter. Don't think it's going to be much better, but okay. Yeah. Okay, so I'm just looping over the breeds and then again over the breeds. Well, first over the breeds, let's say, and then the aliases. I'm simply adding lines for that with high similarity scores. And then again over the breeds again, because I want to match. I want to have each breed name with the next breed name and give a low similarity score if it's completely separate. You give a high one if it's the same one, of course, and then we don't need to go over the aliases because we already do that here. If it's not the same breed, so breed and breed 2 is not the same, then we're going to simply go count the similar words between the breed and the breed 2 name. So it's just the first breed and the next breed, that's the point. And if it has like a Akita in there, then it's going to have a higher similarity than when it has no matching words, and so on. And then I'm going to do the same again for the aliases and the breed names, which is, the intention is aliases from different breeds matching with a non-related breed name. But if it's like American Stafford and Staffordshire Terrier and Pitbull Terrier, for example, maybe there can be some similarities, some points given for word count. So that's the basic ID. Now simply save the CSV file. It could be better. We have highlighted some flaws. What I want to achieve is some kind of similarity search, semantic search. Basically, when a dog breed comes in, then compare it to the other dog breeds and the aliases and find the best match. Again, there's other ways to do this. Search query would be retriever, which is not really applicable, although, yeah, it could be that a dog shelter just puts retriever instead of a golden retriever or Labrador retriever or flat coat retriever. And then we basically have a guess, well, we'll need to get the best similarity, but that could definitely still be wrong. Install the packages, Microsoft ML, then the TorchSharp good old Windows. If you're in a Linux, do Linux. Microsoft ML TorchSharp, using specific version numbers as well, because I'm noticing issues when I go above that, which is a pity because these are dating from 2022, the year 2022, which is about 3 years ago. It's unfortunate that I can't use the most recent version, so maybe that would resolve my GPU compatibility issues. Okay, using all the ML packages, data analysis for the data frames, TorchSharp and tokenizers. The tokenizers was just experimental. Don't worry about that. Then the TorchSharp extension and the Torch distribution to check whether the CUDA is available. It's false, unfortunately. It will give me an error message as well. But I added a notebook, GPU CUDA, to experiment more with that. I added a notebook for tokenization because I thought it was going to help me, but it's not really. Tokenization is not the same as embedding. Tokenization is just splitting the words, preparing the input data before passing it to the model. Okay. Splitting the sentences into words, and sometimes the words into two parts or whatever, and end of line, for example, EOS or end of EOL, going to be tags added for the model to interpret. Okay, model input, sentence 1, sentence 2, similarity, simply loading column 0, 1, and 2. Model output is going to be a similarity score. Then the ML context, GPU device 0, but it's not really capturing anything. Have I tried 1? Put it on 1? Well, but CUDA is not available, so I doubt it's gonna magically work. It could work maybe if we were not in the notebook, in the .NET Interactive notebook. Loading the train data, dog similarities.csv, separator comma this time, header true. Then the train data, sentence 1, 2, similarity is a float. Score is a float. Okay, then let's check out the data by turning it into a data frame. The first 5, Alaskan Malamute with Alaskan Malamute is an exact match, so 5 for similarity. Alaskan Malamute with American Akita, 1. Then we're constructing the trainer, so label column similarity, sentence 1, sentence 1, sentence 2, sentence 2. I did have to add the column name lowercase. For some reason, otherwise it didn't take it. Max epoch, so I'm now doing 50 and batch size 64. So more training samples per that it takes in to train on per cycle. More cycles to train on hopefully for an improved model, but it could also overfit, like train way too much. About that training, I did add data prep to have 63,000 records by adding like all of the aliases again, even if it had like a 1 score, which kind of slightly imbalanced the data by adding too many 1 similarities, which then makes the model biased by predicting a lower similarity score whenever it sees American Akita, for example. Because there's more samples of American Akita being matched with something else and having a 1 score instead of something else. Although I did want to, I thought it was a good idea at first to have to train the model, to teach the model what bad similarities are. But anyhow, even without doing this, we still have plenty of one similarity scores. Training on this 63 only on 10 epochs or something took 2 hours, so I'm not gonna sit through that on the CPU. So I just added this if statement to only capture the ones that have a word count between the breed name and the alias name of more than 1. So it's each other breed trying to match with aliases of another breed and simply comparing similar words like Akita Inu and American Akita. Let's say Akita Inu is and the alias of the Akita Inu breed. Then we should be able to get somewhat of a similarity score between American Akita and that. But okay, so we're already at 79 minutes, 80 minutes. So it looks like, well, we did do way more training cycles. So instead of 10, we went for 50. But we do have way less data now, only 20,000, almost nearly 20,000 rows instead of 60,000. Taking in more samples, so I assume that increases the workload, so on the memory and the CPU, but it should perhaps speed up the model training or improve the model training, hopefully. Anyhow, I'm trying to log the training data. No success so far. Then let's create the engine to make a prediction. So a basic function, prediction, similarity score, for the similarity score for sentence 1 versus sentence 2. And this time I'm just putting in sentence 1 American Pitbull and then just Pitbull. And if we see the similarity score, I would hope it's high because the word is literally in there. And this one should be in the alias of the other one. But, well, we'll see. Well, yeah. Okay, then I'm trying this similarity search instead of just getting the similarity between one and another sentence. I really want to find the breed or the alias that the best matches, let's say, the top 5 or the top 3 best matches. So again, I'm loading in this JSON data first, just analyzing what's in there. Then I do search query. I'm loading in those breeds again, so to loop over them below. Just on every unique breed. I'm not going to loop over all the records in the CSV. It's only 130 breeds or something. And then plus the aliases. So the search query is retriever. Could be a real scenario. As a search result, I kind of want to first have the score, of course, the similarity between the sentence, between the search query retriever and the dog breed in the database, the dog breed name. I want to capture store the search query just to print it out. Then the name is going to be the breed, the breed or the alias name. Then I'm going to set this alias to true if it's an alias, and then the parent name, fill it with the dog breed name if this is the alias, of course. So looping over the dog breeds, first we're doing a breed prediction between the search query and the breed name. Then we add these predictions as the search result. It says not an alias and has no parent name, just 3 values here. If there's no aliases on the breed, oh, looks like it finished. Just in time. If there's no aliases on the breed, we just skip it. Those are all the predictions, else we're going to try to predict for each alias in the breed as well and add it to the predictions. So alias name and the search query. Then, what do we see? So we're expecting scores between 1 and 5. Let's see, I'm getting a 0.9s here. Getting 4.85 between Retriever and Yorkshire Terrier. That's horrible. I'm not sure why, but okay. We're getting somewhat similar between Retriever and American Bulldog, which is not good. Retriever and American Cocker Spaniel, and this, which is not that good. 4.8 American Pit Bull Terrier and Retriever. So yeah, it looks like our 50 epochs hasn't improved the model that much. But anyway, so then the top predictions. Oh, I'm taking 10, okay. Top predictions, well, completely wrong. Say 4.9 for a Retriever and a Bull Terrier. Then a Retriever and a Terrier. Retriever Jack Russell. At least in previous trainings, at least I had like flat coat Retriever as the first result. Then we should evaluate the model. Let's quickly go over how to do that. Yeah, this is pretty bad. It could have to do with the data set. That like yeah, either this combination should be punished. Well, we do have no record for Retriever in the dataset, so that's already a bit more tricky than if we would get Golden Retriever or Labrador Retriever, Flat Coat Retriever wrongly spelled or something. Okay, I just found something new. There's a C# notebooks. It is under machine learning. Maybe there's some more interesting stuff in there. Parameter and search space. Don't know what this sweepable stuff is, but I've seen it before. Sweepable estimators. Anyhow, let's see. And here they do split the data in a train test split. So with a test fraction of 0.2, 20% of the set should become the test set, and then you keep the test set hidden from the model to later evaluate your model performance on. This is text classification, so not what we're doing now. Then we only train the model on the train set. It should be 0.8%, well, 80% of the data. Let's see, then we can, let's just do that. Let's see. Before prediction, perhaps. Oops. Before prediction. Well, yeah, I should have. Let's see. So we've got train data. Just call this data. Very good name. This is data. Then we do train test split is null context dot data dot train test split. Likely seems to be using, I hope it's just data. It's data or data view or whatever, like that. Then train df, we should have train set, if I'm not mistaken. Since we're training, it doesn't want to execute. So that, then training the data. Let's see, this should be this maybe. For train data up for test data test set. Okay. So then the rest can still be the same. Train df, but then instead of this, no, this is good. Training on the train data. Maybe we want to shuffle the train and test data too, could be an idea. So the last fraction of the data is not all ones or all fives. Or okay, then actually testing. So transforming the test data on the model after training, of course. And then we can display the test predictions. And then we should be able to evaluate on it. This is a sample I was looking for. It's from Luis Quintanilla something. I think he works for Microsoft. Let's see. So this is a sentence similarity. This is on the case with the Home Depot products. So looking for a similarity between search query and product descriptions. So product description and search term, and then the relevance. However, they labeled that in the dataset manually, probably. Okay, so I basically just clicked on these links to find that code, which is on samples.net machine learning samples, ml.net 2 samples. Evaluate, this should be the test predictions, relevance and score. This should be similarity and score. Let's see. Columns to select, shouldn't we? Let's see what happens if we just do it like this. Because I might want to see the score if it's already there. And then this correlation comes from a package. I think we've seen the Pearson correlation before, if I'm not mistaken. So what we're doing here is the actual, so we're getting the actual score, so similarity score from the predictions from the column. And then we're getting the predicted score from the score column. And then to assess the Pearson correlation, that's going to be a score comparing the actual score with the predicted score. So similarity, the actual similarity with the predicted similarity. And well, the closer to 1 is going to be, the better it is. If it's closer to 0, it means there's yeah, it was way off. I'll be putting the code in the members only section and on my Patreon, so don't forget to check that out. Like and subscribe if you haven't already. Okay, American Bully, and this should be a similarity of 1. Well, of a bad similarity, and the score is also bad, so that's a good thing. Let's do head. It's good that it's bad. The head, similar stuff. Should likely do like a random or something. Let's see. Oy. Maybe the package is just madnet. Okay. Let's see what we can do here. It's logging a whole lot for some reason. Let's see, Pearson correlation. Is this 1 score? Pearson correlation between the actual and the predicted. So these are enumerables of all the scores. It's got a 0.78. Closer to 1, the better. So that's not too bad. Anyhow, let's take a look at the training now. It was 10 epochs. 10 epochs, batch size 128. How long did it take? 6 minutes, 30 seconds. That's decent. Let's see. No, still no CUDA. Didn't magically turn on. Let's test the model. So we've got some scores again, which the correlation scores are close to the actual value, which is good. These are clearly not similar dog breeds. Now we've got a correlation of 8.5, well, 85, so close to 1. That's pretty good. Let's see. But the prediction between American Pitbull and Pitbull only gets a 1, which is not that good. Should be higher, since this should be a alias from the American Pitbull. Let's then see our search. See a 3 between Tibetan Terrier and Retriever, which shouldn't be. The 3 is not the best, of course. Another 3. This could just be a numbers game, probability. If there's many records for these, and there are only few records with high scores, and it might be biased. Let's see. Top predictions. Again, garbage. German pointer with Retriever. Another German pointer. So basically the same, 2 aliases from the same breed. that are matched for retriever. Then terrier, Belgian Shepherd, oh, mixed breed. What? Sorry, where were we? Terrier retriever from the mixed breed. Well, basically put terrier into mixed breed because it can be any kind of terrier, whether it's a Stafford or a Pit Bull, or could be just a simple Jack Russell or a Red Terrier. Then we have Bull Terrier. We have Irish Terrier. The Terriers seem to be doing good. Again, this could be a numbers game, probability. This Belgian Shepherd also often comes out for some reason. Okay, but nothing useful again. So that sucks. Maybe like a data issue problem. Because yesterday I did train some good models with at least getting the flat code retriever at the top. But yeah. I think that's all for this video. The code is on cascode.com/members or on Patreon. Don't forget to like and subscribe, and see you in the next one.